Hello and welcome to the National Spectrum Consortium Spotlight Series. I'm Sal D'Itri, chairman of the consortium. This is the third in our Spotlight series. These are 5-minute interviews we're doing with NSC members. Today, it's my pleasure to introduce a good friend of mine, Dr. Apurva Mody. He's National Spectrum Consortium Executive Committee member. He's the founder of the TV Whitespace Alliance. And his exciting time has just founded his new venture called AiRANACULUS. Today, we're going to talk about spectrum innovation. Apurva, thanks for joining me.
Thank you, Sal. It's great to be working with you in the National Spectrum Consortium.
Yeah, before we jump into spectrum innovation, I think you and I could talk about that for hours. Tell us a little about your new venture at AiRANACULUS. What are you up to and what are your goals?
Yeah, so as you said, AiRANACULUS is a small emerging technology company. It's a small business established last year. We are in Chelmsford, Massachusetts. We have personnel who have done more than 20 years of path-breaking research and development, as well as technology development and prototyping. Our motto is connecting through innovation and agility in the field of aerospace and defense, as well as commercial sector to solve challenging problems. We do all kinds of work. We basically do work in spectrum dominance, awareness and sharing, wireless communications, 5G and beyond, critical infrastructure, industrial, Internet of Things, smart grid. And we use many different new technologies like, for example, data analytics, data mining, machine learning. One of the things that we can really do is to offer large businesses a great value proposition by partnering with them, both in terms of cost as well as technology.
Seems like a fresh look at spectrum and 5G. So great opportunity for you and excited for you. Let's change gears here and talk about spectrum innovation. I would say in the past 5 years, whether it be auctions or new approaches to sharing, new regimes and new spectrum being brought to market, this has been one of the more exciting past 5 years I think I've seen in the spectrum world. Tell us about your thoughts about what you see today and then what you see possible down the road.
Yeah, so Sal, you and I, we have lived through this whole thing. We've been there for 20 years. Ever since all this thing started. So it's been a long road for us. And I think that I totally agree with you. Lots of great things happening in this space. Although, great things are happening, we still need to do a lot of, make a lot of changes and have a lot of innovation. What I feel today is that we have these, what we call software-defined radio systems. These software-defined radio systems don't really truly use the sensing and the cognition and the machine learning advances that have been made. I think the time is right for really, truly cognitive, dynamic spectrum sharing to come about. And by that, I mean is that, you make decisions on the fly, you have edge compute. What we need to do is we need to make like 100x faster decisions, decisions at the operational tempo, decisions at the tactical edge, where the primary users can share the spectrum with secondary users. The secondary users don't create interference. They take into account all the degrees of freedom. If we go into adversarial territory, we can do the same thing. We can have many different sets of policies like permissive, restrictive. In adversarial situations, we can switch to some other modes of operation, like, you can use interference cancellation or interference mitigation or cognition, right? So I think that those things, they're there. The technologies are there, but I think the time is right for us to bring those innovations into the DoD systems.
Yeah, I agree with you 100%. You're talking about moving at cloud speed in the spectrum world, something that has not been done before. And as we talk about future engagements for the military, it's definitely going to be cloud driven. Tell us a bit about private networks. You talked a lot about edge compute in that, but do you see the advent of private networks as helping to drive a lot of what we're seeing in 5G for the military and also in the commercial network here in the United States and also overseas?
Absolutely. So, in the United States and elsewhere, 5G, millimeter wave, they have created this infrastructure and cloud play. We truly don't really understand what are the ways in which we can use this amazing infrastructure that has been created and the true capabilities of 5G. But I'm pretty sure that the companies within the National Spectrum Consortium in the United States, they will create outstanding applications that will truly use the private networks that will be able to exploit the cloud and the infrastructure, and the roadways that have been laid for us. What I see, some other applications are things like network slicing. So network slicing has got both the commercial play as well as the DoD play. Network slicing can be used in smart grids, smart homes, in many different ways. It can create service level agreements. It can give you the quality of service and better rates. And you can bring those same innovations into the DoD as well. Think of some DoD system that is critical and it requires some sort of service level agreement and guarantee. And we can provide that, right? We can provision that. So just as we used to have this thing called as MySpace, right? I think we are headed towards a future where every system will have its own MySpectrum.
I love that. We need to trademark that. I want my own spectrum. But I think you bring up an important point is the marriage of network slicing and spectrum slicing as the sort of maybe the evolution of where we're at today in spectrum sharing and 5G technology, and how that would provide such an advantage to the warfighter across a wide range of applications, not just radio communications, but other areas, mission critical applications, commander's intent, and other things that where the Department of Defense and the commercial industry could come together to create innovation. Tell us about where you see going forward with things like artificial intelligence and machine learning. I want to throw those into the mix because earlier you talked about self-driving cars, and that requires a lot of AI and machine learning at very rapid tempos for that to be successful. Tell us about your thoughts in bringing AI and machine learning into spectrum innovation.
So that's a great question, Sal. And we could talk for hours on this subject, but we can't escape artificial intelligence and machine learning. Everything that we breathe is going to have AI and machine learning algorithms, driving them. What I see is that AI and machine learning is, an ability for us to figure out the underlying probability distributions. When you don't really know what that data is or how you can make that decision, you can gather the data, you can create those underlying probability distributions, and that allows you to make better decision making. There have been a lot of advances in deep convolutional neural networks, deep reinforcement learning. I think the fundamental difference between those and what we do within DoD is that we won't be able to train these algorithms because things and decisions happen on the fly. And that's why we need things which are based more on experiences, which are based more on incremental learning. And so that's going to be the difference as we move forward, especially in the AI and machine learning space.
Right, bringing the spectrum manager, the expert downrange at the pace of the tempo needed to the place needed. I could not agree with you more. Look, that's all the time we have for today. Apurva, many thanks for joining us and sharing your thoughts. Thank you to everyone for watching. Feel free to reach out to Apurva or myself if you have any questions about the National Spectrum Consortium or you want to talk spectrum innovation. Thanks again for watching.
Thank you.